and with this, and we take the summation, and here is the mathematics behind this. These features, the most strong one, it's a posting behavior feature. So spammer, one of the most followed thing by spammer, they would like to use a trending topic in a Twitter. So there is the trending topic hashtag, I don't know, there is a bomb or whatever. There is, for instance, this hashtag, and the trending topic, this one. So we have the tweets, posted tweets by accounts. We have this hashtag. We draw the distribution, the posting distribution time for this hashtag in these tweets. We have a time, okay, this one and this one, this one, and we have also for this also we have the same distribution for this one. So we have two different distributions. They are in a signal processing, two shifted to distribution. In order to take the similarity, we can find the similarity. We can take the cross correlation between them. So if there is a correlation between them, so there will be produced a signal here. So to quantify this in a real number value, we take the area in the cross correlation between those two signals. If the area is great, I mean high. So if the area is high, that means there is a similar posting distribution. So in order to make it between 0 or 1, we normalize it between finding the maximum. The maximum the maximum hashtag used in posting the tweets. So for the experiments, it's almost the last slide. We crowd and annotated data set. We crowd about here 7,000 account. And in order to use machine learning, it should be worked in a balanced data set, not a skewed data set, because in order to have a robust model. So we divided these data sets into 6 balanced data sets, and then we performed learning on each data set and take the average in validating our features. And we compared our features with the state-of-art features, which are about 70 features. And here is a baseline. That means when you consider our legitimate user as a spam. So we computed when we divided to 50%, 50%. That means the accuracy and the precision and recall F measured will be, the baseline will be 50%. So our features perform the state-of-art features in accuracy about 5 or 6%. So in that case, what does it mean? This means that the spammer, our features is strong to identify spammer. Why? Because spammer might be viewed has a systematic posting behavior. So the second thing, and also spammer are recently created. So all of these things ensures our hypothesis. But when we combined our features with the state-of-art features, the results reduced, and this can be explained by a problem well known in machine learning, is that of overfitting. So we have overfitted model. So in that case, we model some noisy instances. In doing the learning model we used here, I just reported the results of random forest when we have 100 trees. And we used in the cross validations to validate our model in predicting unseen data. And as I said, here is 70 state-of-art features, including graph features, user and content features, and our features are 20. Just at the end, this one is spam problem is an endless problem. So there is no solution for this problem, and even for the old problem in emails. So I think it's an endless war with the spammer, because spam problem, it's almost a business problem. because they would like to achieve some money or get some money. So in that case, it's not possible to end this scheme. And also spammers are intelligent person. So okay, our methods now it might publish, so it can be easy to avoid the spam. Thank you for that.
Thank you. Any questions?
I have one question.
Yes.
I'm a researcher in communication, so I can have a different approach. So my question is, you developed this method for cleaning data. This is different. And if I understood correctly, for you spam is about an automatic account that send message. What is noise? What is when you analyze a sample in Twitter? I mean, that you can have it's a real case that we had in some sample. You can have normal people that send the same message that attend all your criteria. So is spam this or not, because it's a human person, and so I don't know how you can apply this in a real case study.
In a real case study, we apply it on our team. We work on a social profiling and so on with Twitter. So we have some spam accounts, and we need to clean this data. And also on the other side, our team work in tweet summarization and so on. So we need to clean all these data collections, okay, as a pre-processing stage, in order to have a clean data set. But in your case, our method doesn't cover all spammer methods. I mean, spamming methods. We just focus on automated spam accounts. At the end, we may have some spammers that may post manual posts. But in this case, when you have a manual posting, it's not effective to arrive your spam content to many users. So at the end, most of the spammers would like to automate the posting. And also they would like to be systematic, not random in posting. Why? Because it's not efficient for the spammer to post now and then in the random way it may post after, then the next post it will be after 2 days. So in that case, I defeated the spammer in an indirect way. So I prevent the spammers to post. So if you post intensively or in a systematic way, I will catch you. If you don't post in a systematic, in a random way now and after 3 days, so in that case I reduce the spam. Okay, I will not catch you, but I will reduce it indirect. So, by the way, our algorithm is not for a real-time detection. Okay, why? Because in order to retrieve this information, we need APIs to retrieve this information. So this is one of the challenges I'm working in my PhD to build a fast detection methods. For example, these methods can be applied for just 10,000 or maximum 100,000 of accounts. But if I have collections, 10 millions of tweets, my methods or the accounts features in general, it may take months to process this. So the current approach is how to possible to filter out large scale of tweets without going in this advanced. Just okay, my methods now, I'm going to do some collaboration with other social networks. For instance, I have a hashtag, million tweets related to hashtag. I would like to go to other social networks to get similar information, okay, to state, okay, this is tweet, it's spam or not. So in this case, I can filter. For instance, I did that actually. I can filter 8 million tweets just in 1 day. But if I use this method, I need maybe 1 year to filter. Because the API is restricted, number of the API is restricted to retrieve information from Twitter.
Other question? So I have one question.
Yes.
According to your paper, you use data set including 50% spam.
Oui.
And so I think actual ratio of spam in someone's timeline is, I think, far below 10%, 5% or
No,
1%.
yes. If you return back to the origin data set, here's the if we took the ratio, it's 1 to 7.
Mhm.
But in order to test your model, you should perform learning on not a biased data set.
Mhm.
For example, if I have a data set, let me say 100, okay? If I have 99%, 99 non-spam account and one account is spam, so it's not effective to perform learning. So in that case, if you classify them blindly, okay, you will achieve 99% accuracy.
Yes, yeah, but I know. But generally speaking, the finding 50% in timeline is easier than the 1% from timeline. Like the example of needle in haystack, you know.
Okay.
So I think
No, I don't find. Again, the percent it's 1 to 7. I just divide this, create 1,000 spam, 1,000 non-spam. Okay, this is the first set, and then the same 1,000.
Okay.
And here, the second 1,000 of legend user, and so on and so on. And we built for each one a model using a random forest predictive model, and we take the average of the performance.
Other questions? No? Thanks again. So maybe I should do last call for missing speaker, Jim Marchand and Christopher
Can I take
Friday. Okay, good. You, okay, this is for you. No? Okay, this is the end of this session, and I would like to thanks to all speaker and participant and the cameraman. Thank you very much.